Hello and welcome. Several nice people on my in the comment the section of the videos have recommended this book because they hear me talking about differential geometry. So I bought it. I even paid full price. I know it's hard to believe, but you know what? This is it's it says an introduction. I guess I need a pre-introduction. It's difficult. It's very abstract. Um, And also, it's actually kind of boring. I hate to say that, but it is kind of boring. So I took a break from it and started looking at something different. I got interested in geometric algebra again. Uh, it really is a very interesting field to me. I think it's because of the same reason I like tensor calculus so much. That's what it reminds me of. But I've only done a little bit in it. I'm not going to give up on differential geometry. I'm going to take a break and I'm going to get back at it with a vengeance because farming starts soon. I get my ass in gear. Okay, so I've just put a bunch of line the segments here. They're all parallel to each other, so that makes it a parallelogram, right? So, what is the area of this thing? This is the beauty of geometric algebra. It takes geometric shapes and turns them into algebra. Well, what we can do here is put our handy dandy, the basis vectors we love, the old Cartesian orthonormal basis vectors in here, and we can turn two of these legs into vectors like this. Okay? So we just turned two legs of this trapezoid, this parallelogram, with two vectors. So now we're going to go to our dot. And we're going to talk about something called the wedge the product. I made one video on this already. So A wedge B, you read it as A wedge B with this little upside down the thing here. And there's the properties of the wedge the product that you need to start with. That is A wedge B is equal to minus B wedge A. So they're anti-commutative. Is that the right word? And the wedge the product of the same vector, A wedge A, is equal to 0. So those two vectors that I just drew on the graphing the software were this. So we had the 2E1 and 3E2. We're going to wedge that with 3E1 plus 1E2. Okay? So we're just going to do the traditional, the first 2 times 3 is 6, E1 wedge E1. Outer 2 times 1 is 2, E1 dot E2, wedge E2. 3 times 3 is 9, E2 wedge E1, and 3 times 1 is 3, E2 wedge E2. Now let's look at this property here. A vector wedged with itself is equal to 0. So that gets rid of this one and that one, all right? So we only have two left. Now look at this other the property. A wedge B is equal to the negative of B wedge A. So I've got a 1 wedge 2 and a 2 wedge 1. So I'm going to change this one to a 2 wedge 1, which just makes it a negative. And now I have the same thing in both expressions, so I can factor out a E2 wedge E1, and I get minus 2 plus 9 E2 wedge E1, which is a 7. Now, what does that mean? What is this? Well, they call this thing a bivector, okay? And this is the component of it. So let's go look at it. Okay, so we did A wedge B, and the way it's explained is you're going in this direction, so they call that clockwise. And if you did B wedge A, you're going counterclockwise. And this thing here we're looking at, this polygon is the bivector. So it is a multi-dimensional vector. It is a bivector. It's a plane. So it's kind of like taking the outer product of a tensor. If you take the outer product of two vectors, which are tensor rank 1, you can get a tensor rank 2. So it's kind of it's similar to that, but different. Anyway, you saw back in that when we did the document that we got a number 7. Well, that actually turns out to be the area of this. That is the area of this, the parallelogram. So that's what I mean by it takes geometric objects and you can turn it into algebra. Now, if you want to check what the area of this is, I mean, you could do the base times height, the trick, but I'm not sure what the height is here. You'd have to find a right angle here somehow and then know what that number is and multiply them together. The actual easiest way to check that that is correct is just to take the product of this. So the magnitude of the product would be the magnitude of A times the magnitude of B times the sine of this angle. And I forgot to include that angle. And it is, there you go, 38 degrees. So the magnitude of A times the magnitude of B times the sine of this angle is 7. I just checked it. And that is the area of this, which we also got from the wedge, the product. So I just thought that was fun. I'm going to keep doing a little bit more of this, the geometric algebra. I really like it. All right, see you later.